All right, it's Mr. P. with Precal. This is Unit 2, Topic 1, Lesson number 5. We're talking about graphing log functions. Find the inverse of the function and find the identical values. Okay, so if we're going to try to find the inverse of this function, we're going to switch the x and the y. So we're going to push the x over here into the y spot and switch the y over here. All right, so the first thing I would do to solve this equation, I want to isolate y, get y by itself. I'm going to subtract 5 from both sides. That gives me x minus 5 equals log base 2 of y. Now, right now, y is log base 2 of it. The inverse of it would be 2 to the power of. So I'm going to exponentiate, and I'm going to put a 2 underneath and make log base 2 of y the exponent of that base of 2. So if I do that to one side, I have to do that to both sides. So x minus 5, I exponentiate and make the exponent of the base 2. Now, from the basic properties, we learned that anytime this base of 2 to the log base 2 of y, so anytime this base and this base are the same, then they basically just kind of cancel out, and the y ends up being the answer. So we end up getting y equals 2 to the x minus 5. So the inverse function is 2 to the x minus 5. All right, so now we have the original function and the inverse function, so now we can start evaluating. So f of 8, so I'm going to use this first function, so that's going to turn into 5 plus log base 2 of 8. Now, log base 2 of 8, we can easily change that to the number 3, because that's asking what power of 2 is 8. 2 to the third power, 2, 4, 8, so that's 3. 5 plus 3 makes 8, so f of 8 is 8. F of 1/4, that's going to be 5 plus log base 2 of 1/4. Log base 2 of 1/4 is negative 2 because it's changed to the reciprocal, which means you know it's going to be a negative exponent, and 2 to the second power is 4. So log base 2 of 1/4 is negative 2, plus the 5 makes 3. So f of 1/4 is 3. Now I'm going to use the inverse function, f inverse of 2. So I put 2 in for x here. So 2 to the 2 minus 5. Well, 2 minus 5 is negative third power. 2 to the negative third power is the same thing as 1 over 2 to the third power. So the answer here, f inverse of 2, is 1/8. F inverse of 10. So if I put 2 to the 10 minus 5, 10 minus 5 is 5. 2 to the 5th power is the same thing as 32. F inverse of 10 is 32. Alrighty, and let's get into it. So graphing. So when we have an exponential, exponentials and logarithmics, if I didn't already mention that, are inverses of each other. So we're going to first graph a log using its inverse and what we know about the nature of inverses. So I'm going to use 0, 1, 2, and 3. So if I plug 0 in for x, 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So if I plot those points, 0, 1, 1, 2, 2, 4, and 3, 8, which is kind of off the grid, we're going to end up with a graph that looks something like this. I know I'm kind of missing my points because it's not as easy to write on here. The domain left and right infinitely. The range is everything above 0. Everything's above the height of the x-axis because there's an asymptote right here. So it happens to be at y equals 0. The further you go right, the further it goes up towards infinity. The further you go to the left, the closer it gets to a height of 0. All right, so now what we know about the inverse, so this is going to be log base 2 of x, that's the inverse of 2 to the power of x. This is what power of 2 is x. So it's the exact opposite. It's the inverse of it, I should say. What we know about inverses is that it's going to have the same input and output, only it's going to be switched. So instead of 0, 1 becomes 1, 0, and then 2, 1, and then 4, 2, and then 8, 3. If I plot those points, what you're going to see is that this time it's going to have a vertical asymptote. It's going to look something like this. And it's going to have a vertical asymptote at x equals 1. So this has a domain that's going to be greater than 0 and a range that's all real numbers. So notice that the domain and ranges are basically switched. That's, once again, another thing that happens with all inverses. The further you go to the right, the further it's going to go up towards positive infinity. The closer you get to 0, if this was x is approaching 0 from the right, then you would say that it's going towards negative infinity. All right, so graphically, when you look at inverses, they're always going to be reflections over the y equals x. That's what you notice about this. Can the base be negative? No, the bases can't be negative. We should Already know that's one of the rules for both exponentials and logarithmics. It's the same rule. X must be a positive. It can't even be 0. It must be a positive number. The reason why that is because if you have like -2 to the second power, so -2 to the second power is going to be positive 4, but -2 to the first power is -2. And -2 to the first power is 1. So it would just jump back and forth, back and forth, back and forth. It's not going to be a continuous function. Therefore, it's not exponential if it's not continuous. Both logarithmics and exponentials are continuous. All right, how can we graph this? Okay, so this is log base 3. So I'm going to choose my x values very carefully. I'm going to choose 0, 1, 3, and 9. Now, I'm doing that for a very good reason because really, first of all, if I plug 0 in for x, what power of 3 is 0? And that would be undefined. That doesn't have an answer. That's actually your vertical asymptotes. What power of 3 is 1? That would be 0. What power of 3 is 3? Would be 1. What power of 3 is 9? That would be 2. So why did I choose these x values? Because this is really 3 to the 0, 3 the first, 3 the second, and I would have done 27 as the next one, then 81 because that's 3 the third, 3 the fourth, and so forth. Plot those points. 3, 1. Now keep in mind we're just getting a rough estimate here, and it's going to look about like this because we're plotting it by hand. The domain is everything greater than 0. Range is infinite. Asymptote is x equals 0, and increasing and decreasing. It's increasing the entire time, and it's never decreasing. All right, so now we get into transformations. So if I plug -2 in for x here, -2 plus 4 is 2. What power of 2 is 2? That would be 1. So this all becomes 1, and 3 times 1 is 3. -2, 3. 0. So if I put 0 in here, 0 plus 4 is 4. What power of 2 is 4? That would be 2. So this all becomes 2. And 3 times 2 is 6. 0, 6. So what you notice here in this case is that the graph has shifted 2 ways. It's shifted to the left. Sorry, it's the same graph as this, only it's been shifted to the left, but it's also been stretched out a little bit, so we'll talk about that as well. Because of this 3, it's going to make it a little bit taller, vertically stretched. So all of these things, just like every other function, the D shifts it up and down, the C shifts it left and right, the B either compresses or stretches it horizontally, and as I mentioned, the A vertically stretches or compresses. Now keep in mind, just like all the other functions, B kind of does the exact opposite of what you would think it would do. So when it's a fraction like this, it actually compresses it and it stretches it the other way around. When it's greater than 1, it actually compresses it. So it's kind of the opposite of what you would think it is, because this like stretches it out when it's a bigger number, but when it's a fraction, it actually stretches it out wider. So to me, I kind of think of this as the exact opposite of what you would think it is. And it reflects it over the y-axis, obviously, when it's negative, just like it does with quadratics. Honestly, the thing about transformations is it's really kind of the same rules for all functions, as you can kind of see in this example. All right, so in this case, what we have here is +3 means it's been translated up 3. So there's 2 schools of thought here. So I can continue doing these like I was before and choosing numbers that make the x values 0 and 1 and the base and so forth by using powers of that base. So in this case, it's just x. There's no plus or minus anything. Now keep in mind, this is of x. The +3 is actually a k, not an h. So if I make this 0 and I make this 1 and I make this 3 and 9 and so forth, I can keep going in that order. So 3 to the what power is 0? Well, that's not possible, so that's undefined. 1, 3 to the power of 0 is 1, so this would be 0. 0 plus 3 is 3. What power of 3 is 3? That'd be 1. 1 plus 3 is 4. What power of 3 is 9? That would be 2. 2 plus 3 makes 5. And then I can plot those points. So 0 was undefined, 1 was 3, and 3 was 4. Let me move myself, and 9 was 5. Now, I am probably going to run out of time here because I'm already at 10 minutes. So I might just kind of skip the key feature questions, just stick with the graphing because that's what this video is mainly about. And I need you to also to understand here that there was a transformation of +3. So one way of looking at it, there's like two schools of thought. Do it the way that I just did or use the transformations. Consider here's the origin. There was no transformation left or right, but there is a transformation of up 3. So this x-axis actually moved up to here, and then this asymptote is here. And now why do I do that? Because once you do that transformation, it's always going to be 1 away from that asymptote, because anything to the 0th power is 1. So if you use 0 for x, it's going to be 1 away. Because it's the inverse of exponential. And the next number above it is always going to be the base away. So the base was 3, so the next highest point is always going to be 3 away. Because once again, anything to the first power is itself. So no matter what the base is, and keep in mind I'm speaking about its exponential inverse. Because that's basically what this is. This is the inverse flipped, so I'm just flipping the x and y basically around. All right, so now this one I have to be a little bit more strategic. I need to choose what makes this inside 0, and that would be -2. Now, in this case, I chose 0 because it makes the inside 0. That was pretty easy. But this time, you got to be a little bit more strategic. What makes this value 1, and that would be -1? What makes this value 4, and that would be 2? So I chose these numbers on purpose. So -2 here makes it 0. That's undefined. If I put -1 here, that makes this 1. That's 0. 0 plus 1 is 1. 2 plus 2 is 4. What power of 4 is 4? That'd be 1. 1 plus 1 is 2. Now, if I was going to choose the next number, I would want to know what it takes to make this 16. So that would be 14. 14 plus 2 is 16. What power of 4 is 16? That'd be 2. 2 plus 1 is 3. Now, keep in mind, I probably wouldn't do this one because it's not going to fit on the graph. -2 is undefined. -1, 1 is here. Most of the time, you're only going to have 2 anchor points. And that's all I've got in this case. So something like this. I know I didn't curve it very well, but I think it will have to do for this video. Alrighty, and we move on. So, oh no, so there's 2 transformations here. In fact, let me change colors here. So we have +1 for up 1. So the x-axis has moved up 1. And -2 means left 2. Keep in mind, well, that vertical asymptote has already been put there. So right here is where it's 1 away, like I mentioned before in a prior question. And then if you go up 1, it should be the base away. 1, 2, 3, 4, and it is. So that's another way of finding your 2 key anchor points as well. All right, I think I might have to make this last one because I am running out of time. Oh, so maybe I'll skip that one. So go to here. So what you'll notice is that 3 is where it's undefined. So you remember our graph? If 3 is where it's undefined, then you know that's -3. So you know in this case that it's going to be x minus 3. And you know that because it's always the opposite. So that's what this 3 tells you. It's always going to be the opposite right here on the inside. And then we have, so this is log base. Now, wherever it's 0 in this case, so this is 4. So this is up 4 in this case, and then 5 is 1 away. So what's important when you look at this is that if this is where it's undefined, and the next one is going to be 1 away, and then the next one, remember we've talked about before, is always the base away. So if this is 3, so if we're starting at an x of 3, and 5 is where it's you know 1 more, so then it's going to be 4 is right here, so that's where it's the 1 away, and then the base is where it's going to be the base away, which is 2 ahead of it. So we know this is log base 2 of x minus 3. So in this case, like I said, so this is where it's 1 away, and then this is where it's the base away from the vertical asymptotes. So that kind of tells you the vertical asymptote. All right, thanks again for watching. I know this is a pretty quick video, and my next video is going to be getting more into solving equations. Thanks again for watching. Have a great day.